So my name is Sachin Agarwal, as Paul said. I work for TD Bank in Waterloo, and in case you want to reach out to me, after the talk or whenever, those are some of the handles where I am, and there's also my email address there. So the title of the talk, right? Fabricating RESTful APIs for Linux. So the fabric is in double quotes because Fabric is one of those infrastructure provisioning libraries that Python has, and it's kind of a very handy tool, and it's something that I used in a little vignette that I created while writing up this talk. So hence the fabricating, and then the RESTful APIs. We all know what RESTful APIs are for Linux. So the theme of the talk is how do you go from command line Linux functionality to driving all that through a RESTful API. So let's get started. So let's talk about enterprise IT provisioning. And there are many enterprises which are not on AWS or Rackspace. Instead, they have their own data centers for various reasons, legacy, data protection, or even cost, right? At a certain scale, public cloud is no longer the most viable option for you. So that means you got to do all that stuff in-house, right? And it used to be that IT organizations were primarily doing maybe email, backups, user management, stuff like that, But in the past 5 or 10 years, even in the infrastructure space, there's a whole explosion of things that an IT organization would do, right? Within, say, a big organization. There's some of those things are just written there, monitoring, you're taking care of security and certificates for all the applications running on data centers, user management, storage, compute, all the traditional stuff. You're also handling all the networking, right? Firewalls, load balancers, all the stuff that you get in that single pane of glass when you log into AWS has to be done internally, right? And this is of course challenging because the traditional way in which IT organizations have worked is that everything is a ticket, right? So I don't know if some of you have worked in a large organization with a lot of legacy in it, but how would you provision a resource? Say you wanted a file share, right? So maybe a mount point to get on a CIF share or something on your laptop. So you would create a ticket with all the information in it, and this ticket would be passed on to a sysadmin or a storage admin in this case, who would check if everything's okay and all the rules are in place. And then he has this magic tool like some arcane CLI. He logs into that enterprise storage array. Maybe it's a NetApp filer or what have you. Provisions that storage, and then all right, the ticket's done, and he updates the ticket, and it goes back to the user. Now, the obvious problem here is that this is from yesterday, right? There's a big human element here which does not scale, right? There is the big bottleneck in the middle. There's a very nice book, actually. It's called the Phoenix Project, which is all about the problems with such IT bottlenecks in organizations where there's this one guy who knows everything, and all tickets go to him. And so there's a huge bottleneck out there. And the other problem is if you try to train up more people, then there will be inconsistency simply because one sysadmin might do a ticket a certain way, and another one might do it another way, right? So 1 year later, if you just clone the ticket and try to run it through your system again, you get something completely different. So this obviously is not where you want to be in today's world. And further on, if you are even thinking about DevOps or CI/CD or all the good stuff that you heard maybe in the last talk, you cannot rely on this ticketing system, right? Because it's going to be slow, and again, every time there is a request for even one single small IT resource, you're going through the whole system again. So it just violates that dry principle that we all Python enthusiasts are so adhering to. So what are we going to do? And we all know the answer in this room. We would write an API for it, right? And truth be said, many of those vendors which create those different IT subsystems which I showed you, like in this picture below, they have gone in and created APIs for their boxes. There's a NetApp API, or there is a there's an OpenStack API. There are APIs for load balancers. F5, which is one of the enterprise load balancers out there, has an API, so on and so forth. But even when they do exist, they're really, they're very generic, and they may not fit the bill of what an organization really needs. For example, I'll say that you take the API to a sysadmin who's been working on this, maybe the networking part of your organization for 15 years, and say, all right, here's the API, here's your CRUD, and go about use it. And he's going to say, hey, wait a minute, I have these legacy scripts which are written in pure bash, which have all the business logic that I need to adhere to the rules of this organization, already inbuilt into them. I've spent years tuning them. And now you're telling me to use create, read, update, and delete on your API to do everything, right? So that's not going to fly with them. And then there's this whole question of automation versus control. Every organization is different. Some organizations have more control, some have less. So for example, in the previous talk, there was hooking up to GitHub to do all your development. Now, is that even allowed in an organization which wants to keep all its code in-house or things like that? So you end up with a lot of ifs and buts when you try to use a off-the-shelf API. But I still want that automation piece. So how am I going to do it? Well, of course, we are all hackers, so we will build our own API. And the big idea, which I think everybody in this room would think of, is, all right, I have this all-important CLI, which has all the functionality which I need, because I can log into that specific box, that F5 load balancer or that NetApp array, and then provision my stuff. So I'll just put a RESTful API over it, and hey, I'm done, right? Because I'll write it exactly to the specifications of what my sysadmin wants. I can give him all those methods and functions that he would like to see. I can even upload his custom scripts every time the create method works, so that it does exactly what he was doing, right? So, and we are done, right? So, all good. And the talk would end here, actually. But there is this issue here, which is about the state of a system, all right? And we as programmers, we live in this golden era when all the tough computer science problems are solved in the databases, right? We write APIs, we write the applications on top of it, but hey, when I talk about ACID properties, I have my PostgreSQL, I have my Oracle, or if I want eventual consistency, I have my, my Cassandra database, I have georeplication, all that stuff. The hard problems are somewhere else, right? I just write the APIs and the code, and hey, it just works. In this case, the state of the system is not just in a database. It's in all those little boxes, in all the configuration files, those arcane things in each of these IT subsystems. And the big issue here is that if you just can't do things like automatic rollback. If the request is not successful, all right, the API will say not successful, but then what did you do on the box, right? So you've changed the state, but you haven't rolled back. So that's the key challenge of creating APIs to drive infrastructure. So there are certain best practices or design patterns that you can start thinking about when you try to create your own API to drive infrastructure. And one of the things I did for this talk was to create a vignette. It's out there on GitHub. It's called Hootie, which is well, it's the name of my son's owl, but it's an NFS Provisioning Vignette, which means it's not a full product, but it gives you all those design patterns that you might use to create an API to drive infrastructure. So in this case, what it does is it creates a Linux NFS server. and it kind of builds this CRUD API in front of it so that you can actually see how provisioning is done, and it tries to address some of these state issues and what have you. So you can go to that GitHub page, and there is a Vagrant installation as well if you want to play around with it. But let's go on and talk about some of the highlights of what you might want to think about when you're creating such APIs. So for those of us who do not know what NFS is, it's just a way to export a directory which is on an NFS server to various clients. So on this server, maybe you have a few hard disk drives and a few solid state drives, and you create a root path on each of those mount points, and then you can create these subdirectories and export each of these subdirectories as a volume, which will then be consumed on those clients that you have. So what do we want to do in our API? At the very least, users want to provision volumes via HTTP, right? Our HTTP API. And then ideally, as we start building out this vignette into more of a product, you need things like user quotas. You need to enforce some permissions. You want to track capacity on all this, all this resource that you have here, so that you don't over provision and stuff like that. So that would be kind of the bare bones system that I would like to create. So how would we do that? This is like a high-level architecture diagram of what you would want to do in some form. So the vignette itself is built on Django as its API server. It uses Django REST framework, and clients come in through all this interactions through HTTP, and then on the back end, of course, these are traditional servers, so they have CLIs. Like I said, we still want to use that old CLI system because it gives us all the functionality and the tools. So you would just log in through SSH, and you would do your your provisioning, whatever configuration commands you wanted to run, or the config files that you change, things like that, right? So pretty straightforward. You're just translating this HTTP world into the SSH CLI world and working through that. So while designing the system, I chose Fabric for all the back-end work, which is all that SSH and interacting with the servers. Why? Because it's agentless, which means you don't need to install something there. And if you think about it, if you have a NetApp filer, they're not going to let you install a salt minion out there or any sort of agent-based provisioning system. So you just use an agentless system like Fabric. And it works over widely available SSH, and it has very good Python integration, not just on the command line, but also if you are incorporating that library, the Fabric library, into your Django code. Why Django? I don't know why I put that bullet there. We all know Django is great. It has a great ORM. There's a Django REST framework, which is which has this browsable API feature. So your documentation just writes itself when you write your code in the Django REST framework. There's a great admin interface, and there are also some great side projects. If you in this particular implementation, we use Redis queues to sort of serialize our requests. I'll get into that later. It's a great project based on top of our queues. So that was some of the technology choices we used, and so, all right. Oh, this is somewhat washed out. I apologize. You can also go to the GitHub page and browse the code. This is basically the models.py file. So how do you start thinking about resources in terms of Django models? And this is one example here. So we said we create volumes for users, and these volumes are basically subdirectories created on a root path, which was the mount point of the solid state drive or the hard disk drive that you're trying to export. And of course, that is contained in the NFS server. And of course, each volume belongs to an owner. And you can have several other properties of your particular resource in this Django model as well. So So the first step is try to think of your resources in terms of an entity relationship model. All right, and once you have that set up nicely, then you'll find that when you start writing your API, you already have the intuition and the sort of background to write your APIs as you need it. So in traditional Django applications and web applications, all the state is usually kept in the database, right? But here, like I said, the state is also within all those disparate boxes that we have. But one of the design patterns which is useful here is try to keep the state changes, like the saves and the deletes that happen in your model, to also track the changes you're doing within your boxes. So for example, here, we are overriding the save method of the Django model save method, right? So what we're doing is we are saying, okay, in the end, please save whatever state to the database, which is the last line here. But before that, also run the execute command. So this is basically a Fabric invocation to log into that box via SSH and do the CLI work. And we keep it within the same save function. And so the key advantage here is that when you start building views, so of course this is for the Django REST framework, but also when you start consuming the same model, say in your admin interface, or if you create your own views in Django, it will use the same function, right? So right out of the box, you can start even creating volumes via the GUI of Django admin, because it is going to call this Fabric code as well. So that was one of the design patterns we used in this little vignette. All right, so there's also the question of, we want to maybe track the capacity and the quota per user, because we have a multi-tenant system and different users might be consuming different amounts. We set quotas, things like that. So how do we do that? Of course, we can, within the resources, like within the root path, I can have a certain capacity number, or within a user, I can extend the user profile of Django and get the quota he's using. But there is a little subtlety here, which I want to talk about in this part of the talk, which is about serialization, right? Now, if you think about it, when you work with just a traditional web app, the write to the database is really quick, right? It happens within a millisecond or two, and any sort of contention there or stale values are kind of handled in the database side. So if you send one request and then another request, then you're kind of sure that it goes one after the other into the database to modify the database. But in this case, let's say request 1 comes in, and you check the capacity and user quota. All right, this person needs an NFS mount, and everything's OK. So let's hand it over to Fabric, which will go in and then provision that storage in my Linux box using SSH and what have you. But this operation is really long, this yellow box out here, because you're going to SSH into the box, you're going to do that configuration management, changes, what have you. And in the end, you will, if this succeeds, then you will return something, all right, I'm good. And then you do the update on these numbers, these capacity and quota numbers. But then what happens if that same user sent another request right after? All right? And now when you're checking for the, whether you should let him in or not, you're using the stale information. And I cannot do anything else because I do not know whether this command is going to succeed or not, right? So that's the key complicating factor here. And so what do? Well, we need to serialize requests, right? So in order to serialize requests, one of the kind of natural ways you can use is just use the worker queue sort of paradigm, where I use Django RQ for this, but you have different queues corresponding to different entities. So here each queue corresponds to a different route path, all right? And you put all these incoming requests into the queue, and then there is workers, and you can have as many workers as you want to scale up your system. And then they start picking up the jobs from the queues they're subscribed to, and in that way you can always make sure that you're serializing your requests properly. And one of the key benefits here, I mentioned this, is about scalability, right? So if you think about this application that we built, we have Django application servers, right? A couple of them in this picture, behind a load balancer. And you have RQ workers, which are in each, you can run a few in each of these Django application servers. But the state of the system, which is the database and the queues, they live on distributed database and this RDBMS or what have you, right? So you can spawn as many application servers as you want and as many RQs as you want, but you're still going to use the state only from these two systems out here, which are highly available and they never go away. So you can scale up your system as much as you want with this sort of paradigm. All right. So that's some of the code which is in the vignette. If you want to just get started or get a feel of how you might want to go about this this sort of system, users, quotas, queues, stuff like that. But of course, that's a vignette, and if you're planning to build anything for production, there's a whole lot of other stuff that you might want to consider. I've just made one slide for this. One is safeguards. One of the banes of automation is that scripts can go amok, and this happens more often than not. Especially during testing and in your dev environments, for example. So you probably want to do some sort of API rate limiting on your Django application server so that you're not really letting someone take control of your server and bring the whole service down. The other thing is that suppose I'm making the storage subsystem API, I connect it to my cloud, and now on that cloud, what could possibly go wrong? Well, both the aggregator switches HA pair fails, and then the whole cloud has to be rebooted. So you have this huge boot storm. So you will see it in production. So try to make sure that your provisioning service is able to withstand that sort of a boot storm, because unless the provisioning service works, your cloud compute VMs can never come back. All right. So that's something important. And of course, you'd probably want to hook up these Django users to your LDAP AD directory in your organization. You probably need very good monitoring and audit trails, like who did when what, because from my experience, whenever you have a shared resource, especially on the infrastructure side, some part of the organization starts a new service, maybe a new Cassandra database, and guess what? The compaction thresholds are too high, so every other service is impacted, right? And so you want to really have very good information about what's going on the shared resource. Extremely important. Then the second big point here is that you want high availability on the provisioning server. That's easy because I showed you that picture about the load balance and the Django servers. But make sure in your documentation you say this is only for my provisioning system. I don't know about the backend, right? Because just because people read high availability, they think, oh, even my NFS storage is highly available. Well, that's not true. It's just the API server. And this last bullet out here is also something I've seen in production, which is people tend to create a nice web application like the Django application with provisioning within the cloud, which consumes the service, right? So if that cloud goes down, you've lost your provisioning service as well. And if that happens, you cannot bring up any VM which uses this service. So it's a chicken and egg problem. So you probably want to keep this this sort of provisioning service in a different failure domain so that you don't really have that chicken and egg problem where you cannot bring up the VM because the provisioning service hasn't come up because it's in the same cloud. All right, great. So that's the end of the technical part of the talk. I just wanted to put this out there. So we at TD, we are hiring. We have locations, of course, in the GTA, in New York, in Waterloo. If you're excited about working in the infrastructure Python space, please have a look at that website. We're doing APIs, cloud, DevOps, OpenStack is big, Kubernetes, and related technologies, Cloudify, SaltStack, a whole lot of other stuff. And we, of course, we also have some folks working on front end and mobile, Android, iOS development. So I highly encourage you to have a look at that website. And if you have any questions, just send them directly to me. That'll be much faster. All right, thanks. And now if there are questions, we can go to questions. Great, so if you have any questions, we've got a mic over here. Just make sure the mic so we can get you on the once. All right. Great. Thank you. Thanks.